Hello, today we're going to be looking at how to detect voids using ground-penetrating radar and geolytics. Today's dataset comes from Craig Campbell at G3 Tech in Saskatoon, Saskatchewan in Canada. He's provided some noggin data, which is a sensors and software GPR system. And the data comes to us in an encapsulated file called a GPZ file, which is their proprietary GPR file format. Now, some GPT files are actually encrypted by sensors and software. Now, I'm not sure which systems do this. A very simple way of decrypting it is simply to open it in Echo Project and close it again. That seems to decrypt it, and we can now open it in Geolytics. So what we're going to do is simply drag and drop the GPZ file or GPZ file into Geolytics. What I've done already is created here a directory called G3 Tech Saskatoon. I'm going to take my GPZ file and literally drag it in. Actually, first I'm going to create a project. So I'm going to say void detection. And the data tab and positioning tab is going away. So I'm going to go straight to the world tab. I'm going to go into GPR profiles, and I'm going to take my GPZ file and drag and drop it in. Now, what's nice about these files is they usually contain all the geometry information, so you don't have to set up your grids. Everything's already pre-designed for you within the GPZ file itself. So Geolytics is able to bring that in, position everything. Now, of course, we don't know where this is in the real world. It's just an arbitrary coordinate plane. But what we're going to do now is use our automatic processing and automatic slicing functions to process this data. So I'm going to say next. First problem is I don't know what the velocity of this data is. So I'm going to guess at about 0.1, which is a typical radar velocity for, normal soils and typical concrete. I could be off, but let's try that. And what am I looking for here? Well, a void would be a discrete target. So I'm interested in discrete targets. I do want to create slices. I'll go ahead and finish. So what the platform is doing right now is automatically analyzing the data. It's determining the optimal processing parameters to get the most out of the information out of the data. And it's applying those processing parameters so we can actually see what they are here. If we go to GPR profiles, open a profile, here are the parameters it selected, and no two projects are alike. So what the algorithm did is try to find the best processing parameters for this specific data set. We've got our data here. Now, the first thing I'm going to do is it's already created all the slices. I'm actually going to change the color scale to a red color, just so it's a little easier to see where voids are. So here we go. First thing we see right at the surface is we've got some rebar, which we would expect. I guess this is a slab on grade sort of situation. And as we go down, the rebar is very, very obvious. That's great data. We're looking for bright spots. We go right away. Well, look, we've got one right up here at the top, and then another one down at the bottom. So what I'm going to do is our layers are just like a GIS application. I'm going to put the GPR layers on top. And I want to take a look at what some of these profiles actually look like. So here we go. This is our area that's giving us all those strong reflections. That looks very suspicious. I see the rebar on top. There's no change in the rebar, but definitely there's something going on further down below. Let's take a look at one of the cross lines there. And yep, it's there again, right? So this is very interesting. I see a continuous rebar horizon, so that's fine, but certainly something's going on there. Let's take a look a little bit further down, and wow, look at this. There's a very strong area down to the south. Now, is that a real void, or is that something else? Oh, yes. So here's where it is. You can see where my cursor is, where my mouse, and then, of course, the little gray dot on the plan view map that shows me where I'm looking. And right away I can see, hey, something's going differently, going on here differently when it comes to the this target here, because I can see the rebar breaks, and this seems to be a completely different ground surface. I don't have any photographs of the site, but I'm assuming there's a break in the concrete. This might be a metal or some other object here. So I'm going to probably discount this as being an issue, and I'm much more interested in the void up here. So I would say if there is a void, it would be in this area here. And in fact, I can tell that it's going to be in the range of about 40 centimeters. So I'll try and get it at its maximum size, and I can go ahead and actually create a little sketch around it. So let me do that, and I'll add a little rectangular tool, and I'll maybe make it, an obvious color here, and I'll just go ahead and sketch around it. So I can highlight this and export this as a CAD file in whatever coordinate system I might be working in. So there we go. We managed to map a void. What we're looking for are simply strong reflectors that don't belong, right? That we can't otherwise explain. The one at the bottom of this profile or at the bottom of this area seems to be related to a break in the concrete or a break in the rebar. So there's probably something happening at the surface. So we'll ignore that one, but the one in the top, well, there seems to be continuous rebar. Everything else seems to be the same. We just have this strong reflections. And what's happening with the radar in a void is that the radar energy is entering the void and sometimes reverberates back and forth. So we get this chaotic sort of signature from a void structure itself. So that's how we find voids. Thank you very much.